Since I don't need any description of who I am, this first slide, just kind of ignore that. That's the who I am. I've built a lot of tools that you use every day in Python. The new style classes have been out for almost a decade now, and we have a bunch of little tools that people read about here and there, but they typically don't learn how all the tools fit together, and they don't learn it in the context of the problems they solve and the methodology that you use to bring these all together. So I hope to show you that today. We're going to build a simple class. We're going to encounter common problems and show you the Python standard solutions to each of these problems. Individually, these tools are nothing. Collectively, it forms a very good toolkit. So I hope to teach you in a very different way than you've seen before, which is we will do problem-solution pairs. Here's the problem. What is the solution that Python offers to you? Another challenge with the way that people are typically taught classes is you write a class and you test it and you consider yourself done. You don't typically challenge yourself to think about how the users use that class. So in this presentation, in addition to making a class, we're also going to show user code. There's a principle that says every new user will stretch your code in a different way than you possibly could have imagined. I'm going to hope to, through this example, start to raise your awareness of how people will abuse your classes and how you can help them out. Are you guys enjoying your PyCon so far? Yeah. The organizers have just done a fantastic job this year. We really need to thank them. I think everything's just run smoothly. It's really been great. I'm hoping to sneak my child up here and show him off. Again, he's got a cute little PyCon t-shirt on today. All right, let the games begin. I'm going to try and make this lighthearted and fun. I hope you guys laugh a lot as we go along while I'm filling in technical information. By the way, how many of you would classify yourselves as coders? That's good. This is a coders class. There's going to be code on the screen. None of this high-level stuff that you have to do at keynotes. So here's our plan. We'll learn the development toolkit. We'll also see the different ways that users exercise your code. And then I'm going to make fun of our friends up in San Francisco practicing their lean startup methodology / religion. How many of you have heard of lean startup? How many of you have heard of Agile? Is there a relationship between the two? Absolutely. The Agile methodology was designed to get rid of waterfall, where you go quite far in your development before you realize you developed the wrong thing. And the idea was to replace the entire waterfall with a bunch of tight iteration cycles. What the idea is you do a little design, a little coding, a little testing, and then iterate. And that testing and coding phase informs the next phase of the design. It makes you a little bit smarter about what you do so that you don't have to see 10 moves ahead. All you have to do is see 1 or 2 moves ahead. If you're doing the wrong thing, you can adapt rapidly and make a change in your code early on before the code has become heavy. This is the Agile methodology. People will describe it in many ways, but tight iterations and rapid adaptation is its core feature. What is the lean startup methodology? Someone got the bright idea, hey, the way we did things in .com 1.0 was not a good way. Raise $50 million. Spend it all, go to market, and if we had the wrong product, sorry, goodbye $50 million. The new way is to borrow $3 million and to put out a minimum viable product, take it to market, and get some feedback right away and do very rapid, tight iterations so that you're constantly pivoting and adjusting so that by the time you've run out of money, you've achieved what the magic nirvana of product market fit. People pay you massive amounts of money, you become very wealthy, buy an island in Hawaii, or have an IPO at $38 a share and get married. All kinds of good things can happen to you. Hypothetically speaking. All right, let's go back to the beginning. The graduation dilemma. You graduate, you have 2 choices. You can get a haircut and get a real job. Or you could be the CEO of your own startup. I say go for it. Which will be more fun? Let's go do the startup. All right, we'll borrow mom's pension fund to get going. I mean, how badly could that turn out? And so we're going to be the CEO of our own startup, and we'll use the lean startup methodology. How do you spend the first 3 weeks of your time? Thinking up the name of your company in the elevator pitch. But it turned out what we studied in school was we got a PhD in circles. We know all about circles, and the world needs circle technology. We're going to be a circle company. I'm going to save you guys 2 weeks by coming up with your company name, Circuitous, and your elevator pitch. Your elevator pitch is Advanced Circle Analytics Company. How does this apply to your regular programming? I put this in a doc string right at the top of a module. What goes at the top of a module? It's your elevator pitch, what the heck it is you're trying to do. A lot of people skip the module doc strings, so they're skipping their elevator pitch that says what it is they're doing, the quick orientation to the code. Should you skip the elevator pitch? No, it's absolutely essential, but I've just saved you 3 weeks of development for your company. All right, so we have some code. Let's get going, start coding. Let's make a class circle. What do you notice that I put in my class? Did I start with pass? No, I started with a doc string. Did you know I've only typed 3 lines of code so far? The module level doc string, the class definition, and the module or the doc string for the class. 100% of what I've written so far is fully documented. How's that? They didn't used to do that in the old waterfall. Okay, so start with this. Why should you start with the documentation? Well, 1, it's nice to be fully documented at any time. 2, it's particularly nice to be able to run it through a nice tool like Sphinx and get a PDF out of it, hand it to a product manager, and before you've written your first line of code, say, can you go sell this? Or internally to a company, you make the documentation and you hand it to your users and say, can you use this? When is the easiest time to get feedback on the usability of your product? Before you've written it. You will never be more agile than at this point. But I'm concerned. Is this advanced technology? We promised an advanced Circle Analytic Toolkit. Is this an advanced class? No, it's an old style class, unless it's Python 3, in which case it's automatically a new style. I'll assume 2.7 here. So this is not advanced technology. Let's fix it. Okay, we inherit from object. What does that do for you? It enables the toolkit of all the things I'm about to show you. In fact, if you go out and try any of the things I show you and they don't work, the number 1 cause is almost always you didn't inherit from object. When you inherit from object, you get some extra capabilities, things that object knows how to do that old style classes didn't know how to do. This is the advanced technology, just by inheriting from object. Next thing on the list is instance variables. Everyone here has made a class before. Let's remind ourselves of what instance variables are for. Instance variables are where you put the data for each instance that's unique to that instance. If you have anything that is not unique to the instance, does it belong in an instance variable? No. Everybody says no. All of you made classes before, you all know that. Do I go from company to company looking at giant code bases full of lots of instance variables that have nothing to do with the instance? Yes, you see it everywhere. Don't do that. The only thing pertinent to this circle at this point is its radius. We store that varies instance by instance. By the way, is dunder init a constructor? No, you know that because at the bottom of the screen it says it's not a constructor. What is self? Self is your instance. It's already been made by the time init gets called. It's calling the class that makes the instance. So init is often improperly represented as a constructor. It's not. It's an initializer. It takes an existing instance, self, and it populates it, and it takes the radius and stores it in the dictionary. The goal of instance variables is to get the data unique to an instance. The goal of dunder init is to populate that instance for you. I'd ask who learned something new, but I'd really hope the answer is you haven't learned anything new yet. But we're framing the conversation for what comes ahead. Next thing is we need a regular old method. Regular old method, you can tell it's a regular method because its argument is self. Whenever I'm teaching Python, one of the first questions is why does it have to be self? Does it have to be self? No, it could be this. It could be the letter S. Why do we use self? Because it's a cultural norm, and you want your Python to look like Python to other Python programmers. But you could use any variable you want. Why did Quito even require us to put self? Shouldn't it be implicit? In some languages, it is. I think this was a accidentally good design. My understanding is that he spent 3 months building the language with modules and functions and got it working fairly well, but it wasn't object-oriented. He used up all his vacation, and then later he's like, ooh, I need to add in objects. I believe it was done in one day. What he did was he indented all of the defs. He took the functions that he already had and ran them in their own namespace. Class is a namespace. If you actually cut the code out of a class and stick it in a separate module and import it, it looks remarkably like the class dictionary. How many of you knew that what's inside is effectively a module? Did you know I could put print statements in the class definition, and when you define the class, it'll print? You can put for loops in there. You can actually, alongside the defs, open and close files. Unbelievable. This is against the rules in Java and C++. It's not Java and C++. Just saying. So the way the class works is the definitions run as if they were in their own module, and then the module dictionary becomes the class dictionary. Who learned something new now? Cool. And so I believe that the way Guido designed it was he simply indented the functions and stored them in the class dictionary. He needed a way to get to them, and so the only programming that was necessary for that one day was to program the dot. The dotted lookup will reach inside the class, find the function, and then take the first argument and fill in self for you. Hey, what's going on with this 3.14? It's a magic number. It's a constant, right? Just tuck it in. Are we doing things the right way? No, that's not advanced circle technology. We should use reusable components. Let's import from math and use math.py. In what ways is that better? One, it makes sure that we're going to use the same py throughout our code. It's maximizing code reuse. But is pi a constant?
Yes.
How about it's a variable that never changes? There's actually a difference. If you run this code on an old version of Python, you'll get a 32-bit version of pi. If you run it on a modern Python, you'll get a 64-bit version of pi. And if you take the same program and upload it to a Cray, it'll run out to a 128-bit version of pi. Your program will self-adapt when you do things like this. All right, so modules for code reuse. Has this just started out so darn basic you can't believe it? You've only learned one new thing, which was that what runs inside is effectively its own module. We'll go to new and exciting places. By the way, does this code work? Yeah, it's a simple enough class. What are we going to need next? We've done an area for a circle. What should we put in? A perimeter. Sounds nice. How about a color? How about a secant? How about an inscribed pentagon? You're going to need all of those things, right? What's YAGNI stand for? You ain't going to need it. So YAGNI is something people used to toss around as just a random acronym, but now it's part of the religion. The religion of lean startup says, don't load down your product initially with a whole bunch of features. All you're doing is spending your investor money, mom's pension plan, without knowing whether clients actually need it. So part of the discipline is to stop throwing mountains of stuff into your classes. Start with the minimal possible. The more you throw in, the less agile you get. Should we add a whole bunch of things right now and give up our agility? No. What should you do? Commit, push, and that's the agile part of it. The lean startup part of it is, I have MVP, minimum viable product. You ship the product. It is not enough to check it in. You have to stick it into a customer's hands early on to get some feedback. Perhaps they don't need no stinking circles. It's better to find out now before you've spent all of mom's pension fund. Just saying. Okay, so we get ready to ship. I thought I had a shipping on the next one. I guess not. All right. Oh, shared data. We didn't put a version number on. All the instances share the same version number. We use class variables for that. Notice the instance variable is stored in init. Remember, the job of the initializer is to populate the empty instance. But a class variable shares the data. So version is shared across all instances. Should you put shared data at the class level or the instance level? Class level. My version number. I put it in quotes. That makes it a string. Why didn't I do a floating point number? Is version 0.8 plus 0.1 equal to 0.9? Yeah. If you haven't had any bad experience with binary floating point numbers, someday you will. In the meantime, strings work really well. They're easy to parse. Another common way to do the version numbers is with tuples, but it allows some exact comparisons. Little learning point here, don't use floating point numbers for your version numbers. Just saying. You're like, wow, I printed out the client's the documentation for this thing, and they say they're at version 0.1000001. What does that tell you about the quality of the code? Use strings. All right, so we have minimum viable product. What do? Ship it. So we printed up a tutorial how to use our class. We've announced we're Securitas. We can look up our class variable. We can make an instance by calling the class, and we can look up an attribute radius, and we have a method area. What more could a person want, right? shipped out the door, and we have to put it in the hands of some people who can use it. Because remember, your customers inform you in a way that you can't be informed otherwise. If you don't have customers, stick it in the hand of some other user. Every new user will stretch it in a different way. User number one was, nobody would pay us for this, but our friends back in academia, they want our software. And they use it in an interesting way. Their goal is to make a research grant proposal to compute the average area of random circles. They're starting in their proposal with n equal 10, but it is their hope if they get a DARPA grant, they will never have to graduate and can stay in school forever, not getting either a real job or doing a startup, making them very happy. The surprise for us is that they used an n equal 10. You're like, wow, when we made this, we thought of only 1 or 2 circles. These guys may make lots of them. So one thing to anticipate for how people use your classes is possibly they're going to make many, many instances. And these guys are fully exercising the API, taking a look at the radius and making the area call and using a random circle generation. Plus, it gives me a chance to show off list comprehensions. Why did we use X-range here? Memory efficiency. It scales and it's fast. For the most part, anytime you expect n to be bigger than a very small number, always use X-range. Why did these guys seed the random number generator?
So you get
Reproducible results. Oh, that's a new feature in science, reproducible results. How often do you get that? Okay, so new technology. Okay, the next customer is this rubber sheet company. Our friends in academia referred us new customers. This is great because mom was getting worried because customers number 1 didn't pay us. Customer number 2 can write us a check. The rubber sheet company. But they have a special request. They want a perimeter method. Is now a good time to add it? Yes, there is a known use case. There's actually lots of things I've considered putting in the collections module. How many of you would like a binary tree? How many of you would like a skip list? How many of you would like a Bloom filter? Until you ask me for it, until you demonstrate the use cases, we are showing restraint and putting it in. We're shipping the product we know you need instead of, how about I add 500 things to the collections module and you can't find the 3 or 4 that are useful to you. Restraint is important for your customers as well as for yourself. Too many features is a bad thing, in addition to losing your agility. So now we put in the perimeter, and these guys go to use it, and here's their code. They actually cut several holes in one rubber sheet. So one rubber sheet has 3 cuts in it. They make 3 circles, look over it, print them out, and they called area and said it had a cold area. What is this all about? Well, it turns out when you take rubber and heat it up, it stretches. So they did something we didn't expect. They changed the radius. After they changed the radius to allow for the expansion of the rubber sheet, they recompute the warm area. Was this an anticipated use case? Now, I think it's hard to see this one coming. Basically, if you expose an attribute, expect users to do all kinds of interesting things with it. If it's variable, it will change sooner or later. It is not a constant. In this case, the radius of a circle was not constant after creation. How do you guys feel about exposing the radius at the time so that the customers can both look at it and modify it? Who feels icky about that? All of my Java and C++ programmers feel icky about it. Why? Because there's an ironclad rule in the Java and C++ rule and most object-oriented language, and that ironclad rule that you must follow is do not expose your attributes. What should you do instead? Getter and setter methods. People don't get to access methods. But what would that do to our poor client? Look at this line here. What would it turn into? They would have to do a c.getRadius times 1.1, take the result of that and call c.setRadius. Isn't that awful looking code? It made our customers suffer for it. So let's just do things the Python way. In the Python way, it's a consenting adults language. We'll leave all the doors unlocked, and hey, we'll just risk whatever happens to us. Remember, there's no private and protected in Python. How do you feel about exposing your attributes? In Python, it's common and normal. When you go back to the other languages, it's not common and normal, and you absolutely must not expose your attributes because if you need to change the underlying implementation at some point, you are absolutely toast. You are locked into your client code and can't change. In Python, do you expose your attributes? Yes. In other language, do you? Absolutely not. Different rules. Don't let people impose Java rules when they are coding in Python and vice versa. It is a common fault that people who get good at one language inject the rules of that language into another. These are completely different animals. Okay, the next customer is a national tire company. We were referred by...
Why doesn't the same rationale apply about being logged into a customer's use case?
True or false? This is my first rodeo. False. Will I tell you? Yes, at the appropriate time. I set it up. We wait. The tension builds to a climax and knock it down later. I promise to tell you, but not now. How about that? I'm having a good time with you guys. All right. By the way, after we got our rubber sheet company, we got a check in the mail. It wasn't a big check. Mom was happy. Oh, this pension fund's starting to come back. It looks like she may be able to retire after all. But now she hears we might get a national tire chain. That's awesome. These people will write big checks, and maybe we can get out of Mom's back bedroom and get an office down in the Soma district. You know how that goes. No air condition, no heat, but you're hanging out with all the cool people at Twitter and Craigslist and Wikipedia and Yelp and all that sort of thing. So trade the air condition. You're still being paid in stock options, don't get me wrong. You know, not actual spendable green things. So the third customer is the national tire chain. They're the ones that are going to get our office for us. And they need a customization. They track their tires by their inner radius. They're very interested in the inner area of a tire. But when you put a rubber on top of it, its circumference change. And they need to know that so they can do accurate statistics for your odometer and speedometer. So they need the perimeter to do something different. How do customers commonly change your functionality? They do it through subclassing. Most people who write classes don't spend time thinking about how subclassers will use their code. So we're going to see a subclasser do that. They are subclassing tire, overriding perimeter. When they call tire 22, what method gets called? Dunder init. Do you see a dunder init here? No, it goes up and borrows the one from the parent method. When they call area, it goes up to the, it looks first in tire and then into the circle class as the parent. But when we look at perimeter, it looks first in tire before it looks at the parent, and it finds the perimeter. So this is the perimeter that gets called. Now, does the parent get called at all? Yes, we actually refer to it inside our perimeter, so we've intercepted the call and call our parent. If the parent eventually gets called, this action is called extending. If the parent doesn't get called at all, this action is called overriding. So we extend the parent's method, we let them, the parent compute this perimeter, and then we scale it up by 25% for the rubber. This is common and normal. You should expect every class you write, somebody's going to subclass it and do something horrifying to one of your methods. Just saying. Expect it. Is this common in the software field? Absolutely. How many of you know of the language called awk? AWK. The idea behind awk was the people who wrote it were the same people who wrote C and sed, and they said, well, sed is really good at regular expression checking and doing some substitutions. C is programmable. How about we combine the two, a C-like syntax with regular expressions, and their intention was that awk would be a programmable version of sed. They said their jaws dropped to the floor the first time they saw an awk script more than 10 lines long. They never imagined this. I got a chance to interview with one of them at Google, and I showed him a flight simulator I wrote in awk a long time ago. It outputted ANSI.sys. I didn't have curses on the system that I was building on. It actually built all of the instrument displays, and it worked perfectly well. Did they anticipate that use case? You have no idea what people are going to do with your code when you publish it. Just saying. Okay, the next company is a national graphics company. By the way, when we got this tire company, we got written up in Wired magazine. Isn't that cool? A little free advertising. Yeah, Mom's a little more happy now. And so we get a call from the national graphics company. Now, when we're dealing with these big people, they change the rules of the game a little bit. They are not going to take our product right out of the box. They're going to have custom needs. In fact, they have many suppliers. They have a circle supplier, a square supplier, a triangle supplier, a pentagon supplier, and a cross supplier. And they don't want a different interface to each of them. So what they need is a converter method because all they're interested in is the bounding box of the shape. That's how the graphic company manipulates shapes. The properties like radius are something that applies to a particular shape. So they need something that will take their bounding box diagonal, convert it to a radius. Is this a fun way to interact with our class? No, it's tough for the client. They have to use the converter function everywhere. Do I see this sort of thing all the time? Yeah, I go from client to client, and they publish converter and adapter functions. It's not the right way. The API is awkward. What the customer really wants is a different signature. They don't want to have to construct a circle from a radius. They want to construct it from a bounding box diagonal. This is called a constructor war. Constructor wars are typically fought necessarily with customers. They sometimes happen right when you're first creating a class. And when you have a constructor war, several people want different signatures for the constructor. The usual way it's decided is who has the most power. Well, I'm the lead. We will use from bounding box diagonal. Or in this case, the National Graphics Company is the biggest customer. We'll just throw all of our other customers' code out the window and destroy them in favor of our a new client. You've never seen this happen in real life, right? Okay, so there's a constructor war. Brian, what's the right answer? A name parameter is actually a fairly reasonable approach. I say the right answer is whenever you have a constructor war, everyone should get their wish. You should have more than one constructor. If there's a constructor war, people are digging in their positions for a reason. They need that constructor. They shall not be denied. So, is this common and normal? Sure. We do it in Python itself. The one true way to make a date time, of course, is year, month, and date. But perhaps you work with timestamps, at which point that constructor is really awkward. So we give you a second constructor from timestamp. That will convert this timestamp into a date. Some of you just like to count the days from the beginning of the Gregorian apocalyptic calendar, and you know who you are. And that is actually the name of the calendar we use, Gregorian apocalyptic calendar, which I had never heard of before I encountered the datetime module. So you can use the number of days as the beginning of time to compute the ordinal. Or you can just ask for now. These are 4 different constructors from datetime. Now kind of speaks it for itself, but the preposition used here is typical in alternative constructors. You use the word from. So the datetime gives you several different ways to make a datetime object. How many of you knew that already? Okay. How many of you know that Guido and Tim Peters designed this module? How many of you know that they're really good at Python? They provided alternative constructors. Should you do it too? Yes, you should copy all of their behaviors, or at least when it comes to design, not all the other behaviors. Tim Peters, one of the smartest people I know. He also day trades with Python, probably making a fortune, and on Facebook all the time I get little Farmville notices from him. Don't copy everything they do. I'm not kidding, it's true. And then here's one that I put in, dict from keys, that constructs a dictionary from a list of keys. How many of you knew that was there? It goes back all the way to, I believe, Python 2.1. It is not as well known as it should be. It is an alternate way to construct dictionaries. So the solution is whenever people want multiple constructors, you should give it to them and don't decide on one over the other. The technique for doing that would be to provide an alternative constructor via a class method. So in this case, the class method we can call circle from BBD, the bounding box diagonal, and that will convert to a radius and then build a circle. That way a person doesn't need the converter function. They just call the appropriate constructor, just like you would call datetime from timestamp. You can call circle from BBD, and it will make a circle instance for you. Do you dig it? Yes, that is what class methods are for. Yes, sir?
Why do you manually specify circle instead of using the CL?
Is this my first rodeo? Why? Actually, $5 to that question. I used to say $5 all the time, and then Sam started sending me PayPal invoices. So that's bringing that to. So no more verbal $5. It was actually an excellent question. The goal from BBD is to make an instance of a circle. So shouldn't we call circle here? Absolutely. But there's a problem. It works fine for the graphics company. They can call from BBD 25 and make themselves a circle. But it should also work for subclasses. What about these tire people? Shouldn't they be able to call from BBD? They should. But what our code will currently do is call from BBD, which is hardwired to make a circle and not a tire. It is very common for people to devise classes and never think about their poor subclasses. So we failed to think about the subclasses. What do I need in order to parameterize the call to know whether I was called from a tire? If I'm from BBD, how do I know whether I was called from a tire or whether I was called from a circle? Yeah, we pass it in as an argument. So a class method says change the first argument from self to class. We need class as a parameter so we know what to construct. I just changed circle to class. Excellent anticipation of the next slides. Calling me out, just like this morning in the keynote. Where that code doesn't run. That wasn't you, though. All right. All right, so we've got another, so the summary here is when there are constructor wars, everyone should win, provide the alternative constructors. The technique for doing that is class method. The parameter to it is class. Be sure you use that parameter because it will support the subclassing. Thumbs up if you got it. Sweet. Let's drive on. New customer request, add a function. The angle to grade is a function that is a trigonometric function vaguely related to circles. So it converts the angle to radians, computes the tangent, and says that a 5-degree slope is equal to a 8% grade. You know, to help the truckers convert between their tables, between what they see in their inclinometer and what is on their charts that says how good their brakes are going to work. Do you guys like to watch Ice Road Truckers? It's great. You ought to see what Truck Loaded with Dynamite does going up an icy hill, which is a 10% grade, and it doesn't quite make it to the top and slides back. In other words, this is an important problem. So I put this in my alpha release, and I hand it out to them, and disasters ensue. One thing that happens is some people who were working with sphere classes grab our function because it's just sitting out there unrelated to circles. Does this work for spheres? It does not. Spherical trigonometry is different from plane trigonometry. That's why they call it plane trigonometry. So people were using it inappropriately. The hyperbolic people, well, that's right out. Their trig functions are entirely different. They don't even resemble triangles anymore. And more importantly, can people even find this code? They're like, these circle people gave us a circle class. I did a dir of it. I did a help. And I couldn't find angle to grade anywhere. Why not? Because it wasn't in the class. What's the solution? Put it in the class. Indent it. So now I slide it inside. We've got a regular method, and now when people call it, they take an instance of circle.angle to grade. That way the sphere people never call it, the hyperbolic people never call it, and the circle people know where to find it. A lot of improvements. One thing sucks, though. The thing that sucks is really you have to create an instance just to call a function. A hint that you're doing something wrong is we passed in a variable self. Do you see self used inside? There is nothing in this function that needs to know about an instance of a circle. This is an awkward API to call, and you're wasting a variable. What's the solution? Static method. So the purpose of static method is attach functions to classes. Probably you guys knew that, but you couldn't articulate exactly why you would do such a thing. You do it to improve the findability of the function and to make sure that people are using the function in the appropriate context. Circle.angle to grade. It is not used that often, which is why most people don't know what it's for. So if you learn something new, you learn how to articulate its purpose. Why in the heck would you put a function in a class? In part because that's where people look for it. When I was doing some consulting for a company with weather modeling, they had a cloud class and lots of information related to the cloud. People who work with the clouds occasionally need to convert inches of mercury to millibars and back. They're looking for that conversion function. Does that have anything to do with clouds? No, that's a straightforward conversion that doesn't have anything to do with clouds, but people using the cloud kit were looking for it and they needed it then. You put it all the related tools in the toolbox. Okay, the next one, so here's the trucking company making its call, circle angle to grade. It's a nice clean call. We didn't have to instantiate first. The correct context is present. People would not use this with spheres, and the method is findable. Who learned something new? All right, fantastic. Uh-oh, we got a problem, big government client, they send in an auditor, and they're going to tell you not what your product should do, they should tell you how it does it. There's ISOs for this. This is called micromanaging when you tell somebody how to do something. And then they said, we're going to get the big government contract, which would make mom really happy. We get to have our IPO, I'll get a real secretary, paid vacations, office manager. Those stock options might look like something. All we have to do is appease the government to get the big contract. And so ISO 1110, I made that one up, says that you are not allowed to use the radius here in the area calculation. Instead, you must call the perimeter and then back into the radius. The reasoning for this is that at one time they divided a perimeter into an area and they had an inconsistency between the two and it caused an airplane crash. A lot of government rules and regulations that seem arcane almost always have a catastrophe behind them, so there's actually legitimate reasons for other silly rules. So I changed this to call perimeter, and then I back into what the radius is and compute off of that. Was this a simple change? I think so. All problems have simple, easy to understand, logical wrong answers, and this is one of them. One of my problems with the variable name self is it implies that it's you, but it's not you. It is you are your children. Whose code did this mess up? Tire company, they subclassed perimeter. We are not calling our perimeter, we are calling its perimeter. Its perimeter scales it up, so we've now broken their area method. They should be free to override any method they want without breaking one of the other methods. And now we just broke their code. I know what you're thinking, there must be a better way. How about we keep a private copy of it? So here's the problem with the tire company, their perimeter code. And our better way is we're going to make an underscore perimeter equal to perimeter. We will have a second copy of it. We'll say, go ahead and override it all you want, but I'm going to have this self called the underscore perimeter, our original copy. That way the subclasser can override. And you know what? This fixes their code. Doesn't it seem like a great technique? You keep a spare copy of something. That way if someone overrides it, you've still got the original. It seems like a reasonably good idea, but if it's a good idea for you, it's a good idea for them too. So they adopt this idea of, well, we're going to protect our reference here by making under perimeter. Hello? Hello? You're copying me. You're copying me. You're so annoying. You're so annoying. And you're starting to try and win this game. It's the copying game on the playground in first grade. They're copying you and you're like, you're ugly. And they go, you're ugly. Oh, that didn't work. I'm ugly. No, I just insulted myself. How do you win the copying game? The way you win the copying game on the playground is you use somebody's specific name. Heather is ugly. Now, if Heather copies you, Heather is saying Heather is ugly. You won. This is the way, remember, we got a copying game here. Any naming convention they use, we need to do the same thing. So the answer is going to be, the name should be underscore tire under perimeter. And this one, and so if you include your own name, this will refer to underscore circle perimeter, and then they will copy us and do underscore tire perimeter, and we won't have a naming conflict anymore. Clever? First grade skills coming back to save the day in a programming environment. Who learned something new? This practice really works. It works so well, we've automated it for you, and it is the double underscores in Python. Where are my double underscores? There's my double perimeter, and my dunder perimeter got chopped off on the bottom of my slide. Apologize for that. But the dunder perimeter will automatically name mangle for you and rename this variable to underscore circle under perimeter. Then if the tire people use the double underscores too, they'll get under tire under perimeter. Who learned something new? The purpose of the double underscore is what we call a class local reference. We are making sure that self actually refers to you. Most of the time, self means you or your children, but occasionally you need it to be you. People will mistakenly represent this as the way to make things private in Python. Is Python about privacy? No, it's a consenting adult language. We don't leave the locks on the door. The intention of the double underscores was not about privacy. The intention was to use it exactly like this. It's actually the opposite of privacy. It's all about freedom. It makes your subclasses free to override any one method without breaking the others. Okay, we're halfway to a government contract, but we're also in violation of ISO 2222. This is a huge problem. Their new rule is, we have one little change. We looked at your instances and you're no longer allowed to store the radius. You must take the radius out and replace it with diameter, and you can't have both. What code does this break? It breaks our entire class. We'll have to go in and, now we get to keep the API the same. It's how we store it internally that changes. So we can accept the radius in the constructor, or the initializer, but we actually have to store the diameter. And then we'll have to change all the functions that use it and all of our client code, including that which was published in Wire Magazine and the Wall Street Journal. The books are already out the door. We are going to destroy all of our client's code by this change. Isn't it horrific? What is it that we wish we had done in order to access the instance variable for radius? What a Java person would do, getters and setters. If we had just done this from the beginning, we would be able to make this change easily now and store the diameter and look up the diameter. Do you guys understand why now you never expose your instance variables? There must be a better way. We're sitting here right here. We've written these getters and setters and say, oh, I just wish that I didn't have to change any code. I just wish that whenever somebody did a dotted lookup on a radius, that it would magically change to a get radius, and every time they set it, it would magically change to a set radius. And if you wish hard enough, the fairy godmother appears, and it's property. And what property does for you is after the fact, without changing any of the rest of our code, any of our code or any client code, we can add this in, and magically it will, every time we set radius, including in our own code, this will no longer store in the instance variable. This will call this setter and actually store the diameter. This is why in Python you don't have to fear exposing your attributes. Even if you never use property, it's a big win for you. Why? Because Python APIs are clean and beautiful. They don't have getters and setters everywhere. In fact, if you find yourself designing a getter and setter, you're probably doing it wrong. All you're doing is making it awkward for your users to access. Dotted access is a lot easier. If you actually need to make a change later, after the fact, it's really easy to do by putting in a property. This is a big, big win in our language. When I get people coming from C++ and Java, it's the hardest thing for them to give up. They just feel naked exposing their attributes. They're like, oh, get over it. If there's a problem later, we can just fix it by adding on a property. And it's effortless. In the meantime, your code looks very beautiful. Who learned something new? Now you know what properties for. You get a benefit from it, even if you never use it. The benefit is every time you design a class, you don't have to put getters and setters in it. And that'll make your classes shorter, it'll make them run faster, and it'll make the APIs more beautiful. I think it's a big win. It's something you can do in a dynamic language you can't do in a compiled language. Fair enough? Oh, was I clapping because I'm done or because it's awesome? Awesome. And it's this question. Yes, and I clap back to you because it was actually an excellent question. All right. So now we're rich and famous. We've got a lot of money. We've paid back Mommy's pension plan. She's wealthy. We've bought an island in Hawaii and gotten married on the day of our IPO. The problem is when you're a billionaire, you no longer know who your friends are. So your only real friends are the ones that you had before you were a billionaire. And it was those poor academic guys. They got the research grant, and they're going to go out and make 10 million circles to improve mankind's knowledge of average circles. And they call you up, and they're madder than heck. Hey, as we start to scale up, you are eating up an enormous amount of memory. Did you know that every instance has a dictionary? And that between the instance and the reference to the dictionary, our circles are over 300 bytes each, which is kind of big for all they do is store the radius. There must be a better way. How can you shrink down the size of your instance? Yes, it's slots. If you pick up a design patterns book, this is called the flyweight design pattern. The flyweight design pattern says when you have many, many, many instances, make them lightweight, and slots is a way to do it. What slots will do is say, let's allocate just one pointer for the diameter and nothing else, no dictionary. You lose the ability to inspect the dictionary. You lose the ability to add additional attributes. So this is just an optimization. You always save it for last, only when you're scaling up to bajillions of instances. How many minutes?
2 minutes.
2 minutes? Oh, I'm exactly on time. This is good. So you implement the flyweight design pattern, saving it for last by putting in dunder slots. It suppresses the instance dictionary, and it saves an enormous amount of memory, and now your friends are free to run 10 million circles without eating up all the memory on their machine. Who learned something new? Do you do slots first or last? Last, because if you do it first, you lose the ability to inspect the dictionary, you lose the ability to add new variables along the way. But if you stick it in right at the end, you get memory efficiency. And memory efficiency on a modern machine is particularly important because, as we discussed in earlier talks, the cost of a cache miss is as expensive as a floating point divide, and it'll slow down your code right a bit. I'll take questions in about 1 minute. I would like to summarize, unless I truly need to stop right now. What's that?
Did you break tire by adding slots?
I did not. I did not break tire because we have our getter and setter for the radius. It turns out from the user's point of view, there is no change at all. The only people who would be hurt would be a subclass that's storing an additional attribute like color, right? Wrong. The interesting thing about slots, if somebody subclasses you, the slots doesn't inherit. The dictionary suppression capability of it disappears, and so subclassers can add their own attribute. So that's a fine thing. It means subclassers can go about doing their thing, and I have not broken their code. That was an excellent point. I knew that's the one that you intended me to make. I appreciate that. And I actually believe that to be the case. This man knows his stuff. All right, the summary. This is our toolkit. What do you need to inherit from in order to get all these other things to work? Object. I said all these other things. It turns out those double underscores. Did I leave the double underscores off the list? That's because I was out of space. I will add double underscores to the slides before you get them. But the double underscores will work even on old style classes. But instance variables is for the information unique to an instance. Class variable is for anything you share. A regular method is a method that has self. And that, you use a regular method whenever it actually needs self to walk on the instance data. Class methods, their primary purpose is alternative constructors. Whenever people fight over constructors, always implement a class method. It's what I do. It's what Guido does. It's what Tim does. It's what you should do too. They need class. Why do they need it? So that you can create subclasses like tire as well. Make sure you use the CLS whenever you make a class method. Static methods, you can tell a static method because it doesn't need either self or class. Its primary purpose is to attach functions inside a class so that they become findable and so they get used in a correct context. Property transforms dotted access into method access, and this allows you to freely expose your instance variables. It's a very big deal. Slots implements the flyweight design pattern and makes your class lightweight and free. I'll add the double underscores to this for class local references, and you will have 9 tools that professional Python programmers use every day. Who learned something new? Sweet. How's my time? No time for questions?
So do you want them to take questions outside?
I will take questions outside.
Yeah. Okay.
How badly could that turn out? And so we're going to be the CEO of our own startup, and we'll use the lean startup methodology. How do you spend the first 3 weeks of your time? Thinking up the name of your company in the elevator pitch. But it turned out what we studied in school was we got a PhD in circles. We know all about circles, and the world needs circle technology. We are going to be a circle company. I'm going to save you guys 2 weeks by coming up with your company name, Circuitous, and your elevator pitch. Your elevator pitch is Advanced Circle Analytics Company. How does this apply to your regular programming? I put this in a doc string right at the top of a module. What goes at the top of a module? It's your elevator pitch, what the heck it is you're trying to do. A lot of people skip the module doc strings, so they're skipping their elevator pitch that says what it is they're doing, the quick orientation to the code. Should you skip the elevator pitch? No, it's absolutely essential, but I've just saved you 3 weeks of development for your company. All right, so we have some code. Let's get going, start coding. Let's make a class circle. What do you notice that I put in my class? Did I start with pass? No, I started with adaptation as its core feature. What is the lean startup methodology? Someone got the bright idea, hey, the way we did things in .com 1.0 was not a good way. Raise $50 million, spend it all, go to market, and if we had the wrong product, sorry, goodbye $50 million. The new way is to borrow $3 million and to put out a minimum viable product, take it to market, and get some feedback right away and do very rapid, tight iterations so that you're constantly pivoting and adjusting so that by the time you've run out of money, you've achieved what the magic nirvana of product market fit. People pay you massive amounts of money, you become very wealthy, buy an island in Hawaii, or have an IPO at $38 a share and get married. All kinds of good things can happen to you. Hypothetically speaking. All right, let's go back to the beginning. The graduation dilemma. You graduate, you have 2 choices. You can get a haircut and get a real job. Or you could be the CEO of your own startup. I say go for it. Which will be more fun? Let's go do the startup. All right, we'll borrow Mom's pension fund to get going. I mean, how... Since I don't need any description of who I am, this first slide, just kind of ignore that. That's the who I am. I built a lot of tools that you use every day in Python. The new style classes have been out for almost a decade now, and we have a bunch of little tools that people read about here and there, but they typically don't learn how all the tools fit together, and they don't learn it in the context of the problems they solve and the methodology that you use to bring these all together. So I hope to show you that today. We're going to build a simple class. We're going to encounter common problems and show you the Python standard solutions to each of these problems. Individually, these tools are nothing. Collectively, it forms a very good toolkit. So I hope to teach you in a very different way than you've seen before, which is we will do problem-solution pairs. Here's the problem. What is the solution that Python offers to you? Another challenge with the way that people are typically taught classes is you write a class and you test it and you consider yourself done. You don't typically challenge yourself to think about how the users use that class. So in this presentation, in addition to making a class, we're also going to show user code. There's a principle that says every new user will stretch your code in a different way than you possibly could have imagined. I'm going to hope to, through this example, start to raise your awareness of how people will abuse your classes and how you can help them out. Are you guys enjoying your PyCon so far? Yeah. The organizers have just done a fantastic job this year. We really need to thank them. I think everything's just run smoothly. It's really been great. I'm hoping to sneak my child up here and show him off. Again, he's got a cute little PyCon t-shirt on today. All right, let the games begin. I'm going to try and make this lighthearted and fun. I hope you guys laugh a lot as we go along while I'm filling in technical information. By the way, how many of you would classify yourselves as coders? That's good. This is a coders class. There's going to be code on the screen. None of this high-level stuff that you have to do at keynotes. So here's our plan. We'll learn the development toolkit. We'll also see the different ways that users exercise your code. And then I'm going to make fun of our friends up in San Francisco practicing their lean startup methodology / religion. How many of you have heard of lean startup? How many of you have heard of Agile? Is there a relationship between the two? Absolutely. The Agile methodology was designed to get rid of waterfall, where you go quite far in your development before you realize you've developed the wrong thing. And the idea was to replace the entire waterfall with a bunch of tight iteration cycles. With the idea is you do a little design, a little coding, a little testing, and then iterate. And that testing and coding phase informs the next phase of the design and makes you a little bit smarter about what you do so that you don't have to see 10 moves ahead. All you have to do is see 1 or 2 moves ahead. If you're doing the wrong thing, you can adapt rapidly and make a change in your code early on before the code has become heavy. This is the Agile methodology. People will describe it in many ways, but tight iterations and rapid